Now I'll study the CFSE in case of octahedral and in case of tetrahedral. In case of octahedral, low spin, the CFSE is minus 0.4 T2G plus 0.6 EG del naught plus mean pairing energy. In case of high spin, it is minus 0.4 T2G plus 0.6 EG del naught. MPE is mean pairing energy. Del naught is crystal field splitting or DD transition or lambda max or wavelength or maximum absorbance. According to the gate question, TiH2O6, we have to find the energy for 492 nanometer wavelength. So energy is equals to Hc upon lambda. Will not use this formula. Will use the E is equals to 1 upon lambda, which is given in nanometer. Then energy will be calculated in centimeter inverse. So del naught determination from UV visible spectra, we know we should know nanometer is equals to 1 nanometer is equals to 10 raised to minus 7 centimeter inverse. 492 nanometer we have to find energy, so 1 upon lambda will be equals to 492 into 10 raised to minus 7. The energy unit will be centimeter inverse. Then we will calculate, so it will be 20325 centimeter inverse. Now because it is D1 configuration, so CFSE will be minus 0.4 del naught according to the formula. Then it will be equals to minus 0.4 del naught. We have calculated this, we'll put this and we will get a minus 8130. So also we can convert it by formula. 1 kilojoule is equals to 83.6 centimeter inverse. Now we will calculate the CFSE for each D1 to D10. D1 it is minus 0.4 into 1 because in T2G 1 electrons, so it will be minus 0.4 del naught for high spin and low spin both configuration. For D2 it will be minus 0.4 into 2 is equals to 0.8 del naught because 2 electron in T2G. So high spin and low spin both cases it will be minus 0.8 del naught. In T3 configuration it will be minus 0.4 into 3 because 3 electrons are present in T2G, so minus 1.2 del naught for high spin and low spin both cases. Now for D4 cases, for high spin it will be minus 0.4 into 3 and plus 0.6 into 1, as you can see, into del naught, that is minus 0.6 del naught. And for low spin all the 4 electrons will be in T2G, so minus 0.4 into 4, that is minus 1.6 del naught. For D5 case, for the high spin case, minus 0.4 into 3 plus 0.6 into 2 del naught will be equals to 0, and for low spin all the 5 electrons will be in T2G, so minus 0.4 into 5, that is minus 2.0 del naught. Now for D6, 4 electrons will be present in T2G and 2 electrons in EG, so be minus 0.4 del naught for high spin. For low spin all the 6 electrons in T2G, so minus 0.4 into 6, that is minus 2.4 del naught low spin. For D7 case, minus 0.4 into 5 in T2G and 0.6 into 2 in EG, so minus 0.8 del naught high spin. And for low spin it will be minus 0.4 into 6 plus 0.6 into 1, that is minus 0.8 into del naught. For D8 configuration, for high spin and low spin both same because 6 electrons will be in T2G and 2 electrons will be in EG, will be minus 1.2. And for D9 also, high spin and low spin both cases CFSE will be same, that is minus 0.6 del naught. And for D10 it will be 0 because it is symmetrical. Minus 0.4 into 6 plus 0.6 into 4 will be equals to 0. If the del naught is larger than pairing energy, it will be low spin complex. If del naught is lesser than pairing energy, it will be high spin complex. If del naught is equals to pairing energy, then high spin and low spin will be equilibrium.